Hey guys, so today we're going to be talking about something called function notation. Function notation is another way of writing a typical function, like the one up here that we've seen before, y equals negative 3x plus 7. So function notation, which you guys saw in Bungee Physics, rewrites y as f of x. So instead of saying y, we say f of x, and it will equal negative 3x plus 7. This is the same thing written in two different ways. So we're replacing y with f of x. So we can use this to solve the equation, find our output for any given input or x value. For example, we would write f of, let's say, 2. Which we're saying that when x is 2, f of 2 is negative 3, replacing x with our 2 again, plus 7. So we can evaluate when x is 2 what f of x would be. And if we do the math here, negative 3 times 2 is negative 6, plus 7, we end up with f of 2 equals 1. All right, so let's continue this conversation about function notation. So with our function from before, f of x equals negative 3x plus 7, we actually saw this earlier as a do now. So if you're looking at your do now from February 5th, you'll see this function right in there. And I'm choosing some values from a table, my x and my y's. Now, notice I wrote y as f of x. This is the same thing as y, right? Because this could just replace y, f of x, and y, same thing. So one way you'll often see function notation used is they'll ask you, what is f of, let's say, 0? F of 0 equals blank. So when you see function notation written in this way, your 0 is your x value. When the function has the input of 0, what is our output? Well done. All right, so in the last video, we saw a table that was coordinates from f of x equals negative 3x plus 7. We used the table to figure out what f of 0 was. Sometimes they're going to ask you a question like this. What is the value of f of negative 3 when f of x equals negative 3x plus 7? So in this situation, we aren't given a table. We're given f of negative 3, and we have to figure out what this value is. So at f of negative 3 is still our x value, which is our input. All right. We know that x at negative 3 gives us some y value or output, which is this whole thing right here. Output or y value. So now let's figure out what the value is for the function at negative 3. What is our output? F of negative 3. Every time we see the letter x, we're replacing it with negative 3. So f of negative 3 equals negative 3x. What is our x? Negative 3. Plus 7. All right, negative 3 times negative 3 is a positive 9, plus 7 equals f of negative 3. All right, 9 plus 7, 16. So f of negative 3 equals 16. So the value of f at negative 3 for this function is 16. All right, everyone, while we're reviewing some different topics, let's do something we've done previously. Revisit determining the function rule of a line from a graph. So our question is, what is the function of this line? All right, the first place I'm going to start is the equation of a line, which we've always known as y equals mx plus b. We also know that y can be written as f of x equals mx plus b. And this is a reminder that this f could be any letter, whatever you want it to be. A lot of the time it's also written as g, but we're going to use f for now. So if f of x equals mx plus b, then we need to figure out what is m, what is b. All right, so m is our slope, which is rise over run. I know you know it. And b would have to be our y-intercept. I'm going to shorthand that, but y-intercept. So our y-intercept is where our line crosses the y-axis, so our vertical axis. So if I'm going up and down the vertical axis, I see that this point right here is where y crosses it, or where our line crosses it. What is this y value? All right, I hope you thought about it. The y value is 7. So b, I'm going to steps over here. B is our y-intercept, which is 7. So b equals 7. Our next step is figuring out the slope. First off, is this slope negative or positive? It is negative because the line is going up to the left, or I like to think it is going down from left to right. So as x increases, y is decreasing. So we know our slope is negative something. The best way to find out what that something is by looking at the rise over run. So you could take 2 points and plug them into the equation that you might know, y2 minus y1 over x2 minus x1. I prefer on a graph to just count. So I look for points where my line crosses at a nice, neat place on my graph. See, like right here, I know that the x value is 4, the y value is 2. Pretty point. Right here, I know my x value is 0, my y value is 7, a nice pretty point. So I can just count the vertical change and the horizontal change. Make a little triangle. So our vertical change and our horizontal change. Our vertical change is 1, 2, 3, 4, 5. From 2 to 7, our vertical change is 5. And our horizontal change from 0 to 4 is 1, 2, 3, 4. So our slope, which is rise over run, we have a rise of 5, because that's rise up and down vertical. Rise of 5. And a run side to side, like you would run, of 4. We know that our slope is negative because the line is going down from left to right. So the equation of our line, the function of this line, f of x equals m, which is negative 5 over 4, x plus b, which is 7. All right, well done. All right, guys, so your math career is about to get a lot more interesting. Now that we are officially in Math 1, we are talking about things that look like this or many other shapes, which I hope you guys enjoyed discovering on February 5th. This shape is called a parabola. And it is part of a quadratic function. And later this semester, we're going to learn all sorts of exciting things about it in more detail, but that's a little overwhelming for right now. So let's just talk about a few main features that you need to know of quadratic functions and parabolas. So I think the first thing to note about quadratic functions, again, just the light overview, is that they're symmetrical. So quadratic functions are perfectly symmetrical. If you folded this in half, it would fit right over itself again. So think about the letter U. When you draw a U, it should be perfectly symmetrical. And that is exactly what a quadratic function or a parabola will look like. It can be this way, or obviously it can be this way, like in our graph here. So this is a graph of some sort of height over some sort of time. So think about when you throw a ball. Your ball goes higher in the air and then it starts to fall until it hits the ground. So maybe we're squirting from a sprinkler system, and like think about sprinklers, water squirts up from the ground in a perfect arc and then hits the ground again. So say that's the way, in this scenario, say we're squirting from sprinklers or something. So for this function, there is a point where the graph is at its highest, and this point has an x and a y value. Let's figure out what that is now. So its x value, or how much time has passed, is on this axis, our x-axis. And at the highest point of our graph, that x value is 2. At the highest point of our graph, the y value, or height in meters, is at, this might be a little hard to tell in the video, but it is at 12. So our function's maximum value, our highest y, is at 12. And you can find that when x is 2. All right, so thinking about this, our ball or our water or whatever you're thinking of gets higher in the air, and at first it's pretty rapid, and then it starts to taper off, and then at this point, it's kind of at the highest it'll go, it changes direction and it starts to fall. So at the beginning, the function is increasing. There's almost a split second of nothing happening. There's that one point. And then after our highest point and our point of symmetry, where our line will be, the graph starts to fall. So you could say that this graph is increasing from 0 to 2. From 0 to 2. And then our graph is decreasing from 2 to 4. All right, so the important pieces here is, can you identify the highest point on this graph? Can you identify where the graph is increasing? Can you identify where the graph is decreasing? If you can do those 3 things, you'll be successful on your test. All right, so let's review finding slope from a table, which we have a lot of practice with, but let's just do one more example together. So in your notes for finding a slope from a table, our steps are: find the difference between 2 y values, find the difference between x values, calculate rise over run, and simplify. So remember, m is the slope, which is the change in y over the change in x, which is rise over run. So I want to make it very clear here. This is an example of a linear function, but these points skip in spots, right? We notice we go from -7 to -3 to 0 to 2 to 5, which is not a consistent change. So in order for us to find a slope, we need to pick 2 points, a pair of points, and stick with it. You could pick any pair you wanted. You could pick -7 and 22. You could pick -3 and 14. I've chosen these 2 points here because I noticed that all of these numbers are positive and I think it will be easier to work with. All right, but it's up to you. You can pick anything you want. So, thinking about our ratios and proportions, let's make a ratio to find our slope. First thing is difference between y values. In our y column, the difference between 8 and 4 is 4. And we are going down, so I'm going to call this a -4. Now, step 2, difference between x values. For this pair of points, we have 0 and 2. The difference between these 2 values is 2, and we are going up from 0 to 2. I'm going to call it +2. Now we need to calculate rise over run. So our rise is our y, is our vertical change, which is -4. Our run is +2. So our slope, when we simplify, so m, our slope, -4 over 2. If we divide top and bottom by 2, we can simplify this to -2 over 1, which -2 over 1 can be written just simply as -2. So the slope of this linear function is -2.